Good evening and welcome to the Oliveboard platform. My name is Marut Sharma, your logical reasoning expert, and we are here today to start a new theoretical session of directions. It's a very easy and a common topic, but usually very one question you might expect from this topic. But the thing is that there are some little things which we need to lay focus on that will help us get a better clarity as far as directions is concerned, right? Just give me a moment. So this update, actually I suddenly remembered that some of my students have asked me that how do we get the PDFs of the session. So towards the same, hi Ruben, good evening. So towards the same, I would just like to tell you that you need to download the updated version of the Oliveboard application. Okay. There, firstly, as soon as you open the application, you have to of course log in, then select your examination here. SSC or railways, here you will select SSC obviously, and then at the bottom right corner you will see the option of courses. Click on that, you will get this window, okay, and in this window you will be having multiple options. One of them will be YouTube class PDFs. So all the sessions which are conducted over on the YouTube channel, they will be available there with their timestamps, so you can click on that, download the PDF and access it from there. Okay, so let's start with directions now, but before we start, please, if you are new to the channel, subscribe to it right away and share this video across platforms. For those who may be beginners or who may just be starting, I'm going to talk to you about directions from the very basic, right? So that every little detail is clarified for you. I will share with you some other little tricks as well, which normally I don't suggest you should use, because I am telling you that if you depend on one method alone and you just, master that method altogether, then it will become very easier for you. But again, for everything, we might have some extra points, so I'll just let you know about everything. Let's start. So before we start directions, we need to have some prerequisites in our mind. Okay. Some prerequisites means you need to have an understanding of some pointers beforehand. The primary thing is expression of directions in 3 different formats, right? So you have to be clear with this concept. Now 3 different formats means format number 1 is right in front of you. So we are talking about 4 main directions. We are talking about 4 main directions. So this is the north, this is south, okay, and here this is the east, the right hand side, and this is the west, the left hand side. Okay, so this is, you can remember it like this, NEWS. So this is how it travels, right? Now, these are the 4 main directions which have the angle of 90 degree between them. So, they have the angle of 90 degree between them. So, each main direction has an angle of 90 degree between them, right? Now, apart from these 4 main directions, we have 4 cardinal directions. Cardinal means sub-directions. So, between each of these main directions, there lies a sub-direction. So, this is a sub-direction, 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 sub-direction. Okay, and how are these sub-directions named? They are named like, primarily the name of the vertical direction will be written and then the horizontal. So we'll have northeast, northwest, we have southeast, southwest. This is how they are named. The angle between 2 cardinal directions is also 90 degrees. So the angle between 2 cardinal directions is also 90 degrees. So if I say this angle is also 90 degrees. Okay. Now, the angle between one main and one cardinal direction is 45 degrees. So, this angle here is 45 degrees. But there is a crux which you need to know. Okay. When I am talking about the north, south, east or west, then they are strictly along these lines only. This is the north, this is the east, this is the west, and this is the south. But if I am talking about the northeast is not specifically only on this line. Rather, the northeast is depicted by this complete quadrant. This complete quadrant here is northeast. This complete quadrant is northwest, southwest, southeast. So any point here will be considered in the northeast as compared to this origin point. Okay. So that is the first type of direction which you need to be careful about, which you need to be aware about. The second type of direction is in the direction of clock. Supposedly this was a clock. Okay. So if this was, let's say this was 12, this was 3, this was 6, this was 9. So how do the hands of a clock move? In what direction? If it is 12 p.m. right now, how will the hands of a clock move further? They will move always in this direction and they'll continuously keep moving in this direction, right? So this direction is known as a clockwise direction. This direction, movement in this manner, that is first north, then east, then south, then west, that is clockwise. And if I am moving against the clock, see, before 12, I mean after 12 I cannot have 11, 10, 9, so the clock is never going to work like this. So this is opposite the clock, also known as anti-clockwise. So from north if you go to west, south, east, if in this direction if you are travelling, then it is anti-clockwise, this direction it is clockwise. Be careful about this. This is the second method of expression of directions. So first method is this, second is this. You need to be aware about these two. And the third one is the most important actually. Of course, everything is important, but the third one is the primary place where students make mistakes. Hi Dinesh, good evening. Primary pointer where students make errors is here. Okay. So the third case is left right. Now, as far as left right is concerned, left right changes with the changes of where I am facing, the direction of where I am facing. If I am facing you right now, for me this is the left, this is the right. Okay, maybe for you it is appearing laterally inverted. If I am facing here right now, this is the left, this is the right. If I am facing here right now, this is the left, this is the right. Okay, so wherever my face will be, my left and right will accordingly change. So how do I remember it easily if I am drawing a diagram? The easy way to remember is wherever I will draw an arrow, I will assume my head to be in that direction. So my left hand in that case will depict the left direction, my right hand will depict the right direction, because my hands are not going to change the direction anyway. So if I am facing the north, this will be the left for me, this will be the right for me. If I am facing the east, this will be the left for me, this will be the right for me. If I am facing the south, this will be the left, this will be right. See, for north and south, they will just get flipped instantly. So be careful. And if I am facing the west, again west and east, they will get flipped. So this is the left, this is the right. That's how it works. So left and right will change according to the face direction of my face. Wherever my face will be pointed, left and right will accordingly change. So these three categories of directions need to be clear in your head before we start understanding what exactly is the topic and how do we need to proceed. Okay, we have still not started officially. This is just some prerequisites which I am sharing with you. Okay, now, so the next method now, we are learning the method, we will start learning the method, that is path tracing. Now, in path tracing, normally what happens is directions comes under the category of questions of logical reasoning, where there are a set of instructions given, you converted that into a form of a figure because it becomes easier to decipher, easier to understand, and then you answer the question. It is like blood relations or maybe some other topic of that category, right? A puzzle, sitting arrangement. Now here you need to trace a path as per given in the question. The question will tell you that somebody is traveling a path, you will trace that path and accordingly you will find out the direction in the distance. Okay. So path tracing is done in two methods, in two ways. First is the square of the rectangle method. Second is the Pythagoras theorem method. Okay. Now I'll just give you a brief example about both of them. Suppose there is a person who is starting from his house. So we'll draw the person's house, house. And this person is moving 150 meters in the north. So where will the north be from this direction? I told you on paper in 2D, north will be always on the top. So north will be here. So the person will move 150 meters in the north. Okay. Now from here the person will take a right turn and move 100 meters. Okay. When the person is going to take a right turn from here, so the face is in this direction of the arrow. If the face is this direction, right is here, left is here. Okay. So person is going to go here, right 100 meters. So 100 meters. Now remember, our figures will be drawn always to scale. What does this imply? This implies that if I am drawing a line of 150 meters, okay, and then I have to draw a line of 100 meters, that line has to be shorter than 150 meters, slightly. Okay. I am not saying exactly to scale, I am not saying that you have to find the ratio and all, but it has to be roughly to scale so that your direction is not incorrect. Distance will always be correct, but directions might get incorrect if you draw in, uneven lines. Okay, from here he takes another right and goes for 50 meters. If he is taking another right here, the face is here, so right will be here, and 50 meters is roughly half of 100 here. So we will draw a line like this. Okay, from here again he is taking a right and going 100 meters. So this is how he is going here, and this is his final point. This point F, this is point his house and final point. Now the questions, how will the questions be asked? Question number 1 will be, at what distance and in which direction is he now from the starting point? So this is your reference point, you have to calculate from here. Or the reverse question will be, in which direction and at what distance is his house from his current location? So this becomes a reference point and you have to find here. Okay. So let's see what can be done about this. So when we look at the question carefully, what do we come across? We instantly say, a lot of people say this, that this is 50 meters. My question to you is why? So the answer is, because this was north, this is technically the east, south, west. So basically each main angle has an angle of 90 degree between them. So this is a quadrilateral with all 4 angles as 90 degrees. So it is a rectangle for sure. And also opposite sides will be equal. So this is 100, 100, this is 50, this has to be 50. But each time you don't have to calculate like this. This is the principle behind this. So now you will simply just, carry forward the lengths. So if this is 50, the whole is 150, you know that this distance is 100 meters. Okay. For reference directions, whatever the reference point is, I can just draw a plus sign there representing a quadrant or a coordinate axis. And from this as an origin point, I can see that it's in the north. So he is currently 100 meters in the north of his house, or he is currently 100 meters to the south of his current location. Sorry, his house is 100 meters to the south of his current location. These are the 2 major questions that will be asked. The third most important question which is asked here is, in which direction is he currently facing? Remember, in which direction is he currently standing from his house is a different question, and in which direction is he currently facing is a different question. Remember, don't confuse there. Whenever the word from is used, you have to have a point of reference. From there, they are asking you the direction. But whenever it is simply asking you where is the person facing, then in that case, your last arrow is going to help you. So this arrow depicts in which direction is he moving, and the person is just a peg basically. So you are, whatever your instruction tells, whatever your instruction points out, that is the only direction what he will move. He has no free will. So if in the end you made him stand here, he will stand here looking in the same direction which he was in the final end. So that will make sure that this is west. So what was the answer? The answer is west. Okay. In which direction is he pointing? He is pointing towards the west. Cool. Now let's proceed to the other type. The other type is Pythagoras theorem. Under Pythagoras theorem, let's say the person now again starts a new journey from his house. Also remember, always label these points, because these points sometimes are involved in your questions directly. So you need to recognize which point was which. And he goes 30 meters in the north. Okay. And then he takes a right turn and goes 40 meters. Okay. And he stops here. This is the final point. Now they are asking you what is the distance between his house and the final point. A lot of newcomers mark 70 as the correct answer, that the distance is 70 meters, 30 meters, 40 meters. Those who are seasoned, they already know what is the answer here. So whenever it will ask you the distance in this case, it is not interested in this distance. That is already given in the question. What's the point of asking? The examiner is interested in this distance. Now this distance can be called as the shortest distance between the points, the minimum distance between the points, or the aerial distance between the points. Either of these words implies the same thing. Even if the question is not using any word and if the figure is somewhat of this sort, you will always assume this distance to be the question. Okay. So basically in this figure, if I see, again north and east, so this is a 90 degree, so this becomes a right angle triangle, opposite 90 is the hypotenuse, so I simply have to apply the Pythagoras theorem, simple. So what do? I'll say 40 square plus 30 square under the root will give me my answer, so that is 1600 plus 900 under the root, that is 2500 under the root, which is 50. So my answer now is 50, easy, done. But we don't even have the luxury of this much time in your exam, okay. If at all there is a triplet where you will not be able to remember anything by default and you have to solve it, that's a different case. But otherwise, we can remember sets of 3 numbers which are always following this category, this equation, this theorem. So we call them Pythagorean triplets. I am very sure under quant you have already studied this for your geometry part, triangles, right? If not, you can still remember this, and I have given you a very simple list which is useful for directions in reasoning. For quant, you can extend this further. Okay. So these are some set Pythagorean triplets, common Pythagorean triplets which are usually used in to form your questions. And here if you observe, these two are the normal smaller sides, this is the largest side, so this is the hypotenuse always. So if any of these two are the smaller sides, the third one is going to be the hypotenuse. You have to remember this complete list. Now what is the good thing about this list is, if you pick up any triplet, let's say I picked up 3, 4, 5. That means 3 square plus 4 square is equal to 5 square. In that case, if I multiply it with the same number, the resultant will also be a triplet. And that is why in the previous question, we could have directly written 50. Okay, anything, you pick up 7, 24, 25. Multiplied by 2. You will get 14, 48, 50. That will also be a Pythagorean triplet. Okay. So this will help you to reach your answers much faster. Now 60 to 70% of your questions which will be asked in directions are already covered. We have already done them, we have already covered them, right? Path tracing is the most common method which will be used in direction based questions. This is the next method, that is a shadow based question. Now I will explain to you in complete details, okay, and then I'll also tell you how to approach this question in the exam. So in a shadow based question, the question is in multiple parts. You have to read the question in multiple parts. The question will always begin with a set of keywords, okay. The keywords will be like, they will use the words like morning, or maybe they'll use the word sunrise, or maybe they'll give you a time in the morning, early morning, okay. Or on the other hand, they might use the word evening, or they might use the word sunset, or they might give you a time in the evening, okay. Now first and foremost, what do we understand from these words, from these keywords? The first thing is that they are telling you the direction of the sun. This is solely based on the principle that the sun rises in the east and sets in the west. So if it is early in the morning, or it is time of sunrise, or it is the time is given, you will get your sun, S-U-N, sun, to be in the east. And if it is in the evening, time of sunset, or 6 p.m, the time is given, then your sun will be in the west. Okay. Sun rises in the east, sets in the west. Mostly it is only going to talk to you about morning or evening only. It is never going to talk about another specific time. Let's say it will not ask you at 11 am because the sun has already crossed the east barrier by 11 am. And now that becomes a quant question, that if it moves in this by this much degree in this much time, then by 11 am, that is in the next, let's say if the sunrise happened at 6 am, in the next 5 hours it has moved by this much angle. So this is now my new angle of elevation. So then I will solve accordingly. That's a totally different concept. That question goes to quant then. But right now we are talking about logical reasoning. So it will either talk to you about early in the morning when the sun is in the east, or late in the evening when the sun is in the west. It will not even talk to you about noon because there are no shadows at noon. Technically at noon your sun will be here on the top above your head. So there will be no shadows. So we don't consider that also. So these are the set of keywords. So this is the first information which you got. The next part of the question will tell you that there are two people who are either walking towards each other, walking in a park, strolling, sitting, anything. But there are two people. Okay. So let's say there are two people here, or let's say there are two people here. Now I have drawn them differently. In one case they are facing each other, and in the other case they are facing opposite to each other. Okay. So that is how the question will tell you that two people, they are facing each other. Okay. Or they are facing opposite to each other. That is, they are sitting with their backs towards each other. They are walking away, sitting with their back towards each other, or they are walking towards each other, sitting facing each other. Anything can be said. Okay. So now the question will tell you another additional instruction, another additional information. After giving you this information, they'll talk to you about these two people. They will name these two people, but you will not know who is who. And they'll give you one statement. For example, if I tell you these two are A and B, I don't know who is A, I don't know who is B. So the question is telling me that it is early in the morning at sunrise 6 am. There are two people who are sitting with their backs towards each other in a park, A and B. The shadow of A falls to the left of B. The shadow of A falls to the left of B. So these are the set of instructions. You got the keywords, you got the two people. You know an extra information that the shadow of one person is falling to the left of the other person. With that, you have to identify who is who. That is your first part. And the second part is to answer the actual question. The actual question will be, if this all is true, in which direction is B facing? This is the question. Okay. So what all information will you gather from here now? You will say that if my sun is in the east, it's early morning, the light source is here. That means my sun rays are coming from this direction. See, all this drawing I am doing it for you here so that you understand, but you don't have to draw this in the exam. In the exam, everything has to happen here. You can only draw this at max. Now, when the sun rays are coming from there, where will the shadows form? If this is the object, the light is coming from here, the shadow is going to form here. So the shadow is going to form here and here for both of them. Don't go into deep science, okay? Total layman language. Now I told you the shadow of A falls to the left of B. This person's shadow, this one, falls to this person's right hand side. Correct? This is the left for him, this is the right for him, this is the left for him, this is the right for him. So shadows are falling to the left of who? To this guy. So the shadow of A falls to the left of B. So now I know this is B and this is A. And my question is, in which direction is B facing? So now I know B is facing the north. And where is A facing? A is facing the south. So that is how I answer this question. Okay. Now let's look at this question. What are they saying? They are saying at 6:15 p.m. that is in the evening. Sun is in the west. Ruchi and Dolly are standing face to face in a park. Okay. If the shadow of Dolly falls to the right of Ruchi. Okay. So where will be the light source? This is the light source. Rays are coming from here. If the rays are coming from here, where will the shadows form? The shadows will be here. So the shadow of Dolly falls to the right of Ruchi. For this person it's the right. So right of Ruchi, this is Dolly. Correct? Which direction is Ruchi facing? Now this is where you went wrong, Dinesh. You said south. Ruchi is definitely sitting in the south. No doubts about that. Ruchi is definitely sitting in the south. Dolly is sitting in the north. But Ruchi is facing the north. Ruchi is facing the north. In which direction is Ruchi facing? Ruchi is facing the north. Dolly is facing the south. Dolly is sitting in the north, facing the south. Ruchi is sitting in the south, facing the north. So my answer will be north. Now a few questions come up here. Correct. Good. A few questions come up here from students. Yeah, you are not asking, but I know students ask this commonly. Question number 1. Why only facing each other or with their backs towards each other? Why can't I have a person, those who are facing like this or like this? So the problem is, in both these cases, your shadows will be in the same direction only. Means there is no left and right for any one particular person. I am not saying they can't ask you like this, but then it becomes useless. You can't identify who is who because everything will be same for the both of them. So they'll never ask you pointing in the same direction. Technically, they will always be in the opposite direction only. See, if he is facing the south, D is facing the south, R is facing the north. If B is facing the north, A is facing the south. They will always be facing in opposite directions only, but either towards each other or opposite to each other. Okay. And the next question which a lot of students ask is that why, when the question said that they are facing each other or towards their backs, with their backs towards each other, why didn't you draw them like this? Why only like this? The sun could have been here in the east and they could have been sitting like this also. What's the problem? The problem is then the shadow will never be in the left or right. If your shadow is talking about left or right, this is the only arrangement. If your shadow talks about front and back, which is very seldom, very rare, then your arrangement will be of this sort. So the rays will be coming from here. This guy's shadow will be in the front and this guy's shadow will be at the back. Okay. So that is why if the shadow talks about front and back, then you can draw this figure. Otherwise, this is also not considered. Cool. So that's all about your shadow based questions. Now in your examination, of course, you don't have to draw this. You don't have to draw anything. You simply have to draw this line and understand your left and right clearly. That's it. So if I draw the same question again, let's say Ruchi and Dolly are standing face to face in a park. So they are standing face to face in a park in the evening. So the sun rays are coming from here. Shadow of Dolly falls to the right of Ruchi. So the shadows are going to fall here. Now what is right? Right is this side only. For who this is the right? For this person. This is Ruchi, this is Dolly. Done. Your question is done. You can answer your question and done. Be done with it. Okay. So that's how you'll approach it in the exam. All this diagrammatic representation has already been done, only been done so that you understand better. The next type is the angle based type. Okay. For angle based questions, your question will be something of this sort. A person will be starting from a particular direction. Let's say here the man is facing towards the east. So man is facing towards the east. Now the question will give you multiple angular movements. 135 anti-clockwise, 45 anti-clockwise, then 90 clockwise, and they've only given you 3 angles here, but they can be multiple angles. They can be up to 5 to 6 angles. So you can't just keep doing this to get your answer, no? And you might end up making an error or maybe spending a lot of time. So what is the correct approach here? You will always convert this into a table. You will, rather than moving all these movements, you will just find a single movement. So all your clockwise entries in this column, all your anti-clockwise entries in this column. So let's see 135 anti-clockwise, 45 anti-clockwise and 90 clockwise. That's it. Remember, if there is the same number in both these categories, just cancel it out. If there was a 90 clockwise also, we would have just cancelled this. Now add them, vertically add them. So this is 180 and this is 90. Subtract smaller from larger. So 180 minus 90 becomes 90 and take the direction of the larger value. So that is clockwise. So this is my single net movement. This is my single net movement. That is, rather than moving these multiple angular movements, I am just moving one time in this direction. Okay, and I can get my answer. So if the person is here, oh sorry, my bad. This is anti-clockwise and this is clockwise. So this is 90 degree anti-clockwise. This is the single net movement. So if the person is facing the east and he has to move 90 degree anti-clockwise, what will be anti-clockwise? It will be in this direction and 90 degrees like this. So now he will be facing the north. So my answer will become north. That's how easy this is. Just convert this into a table and get your single net movement and answer accordingly. Okay. From here, I want to highlight another important point for you guys. That is angular turns. Okay, I'll write default 90 degree. So in my question, if it suddenly says that the person is moving in so many meters and then turning a right or turning left, so we simply turn them like this. Supposedly if I am talking to you like this, that a person is moving north 10 meters and then they have taken a right and then they have gone 20 meters. So then you will automatically turn him here. Then they have taken a left and 30 meters. So then you will automatically turn here. So what are you doing? Wherever the person is facing, you will accordingly decide left and right and keep moving. But technically you are making a 90 degree turn, no? So by 90 degrees by default. Okay. How did you get this 90 degree? How did you get this 90 degree? Let me show that to you. So let's say a person is going from a point A. A person has started his journey going 10 meters north. Okay, so I am moving him 10 meters north. From here, he is taking a right turn and going 20 meters. Now, how do I turn a right? So technically, the question will become like this. In whatever direction I was supposed to move further will become my base. This will become my base. From here, I have to turn a right. So right will be this side, left will be this side. Okay. So I have to turn a right and go 20 meters. And nothing is given, so default turn is 90 degrees. So I'll just draw 90 degree, keeping this as the base towards the right. So this is going to be my 90 degree. And this person will go 20 meters to reach this point. Okay, so that is why I directly turn it like this, because not this angle, but this angle has to be 90. Okay, got it? Now the question changes. Now I am telling you that he further goes 135 meter to the left. 135 meters to the left. And let's say he goes another 10 meters. Now when I say 135 meters, that becomes problematic for a lot of students because they don't understand this concept. So I have already told you, baseline, this will extend. Okay. From here, this is the left, this is the right. He is going 135 meters in the left. So from here, from the base, you will draw 135 meters. And you will take him to the left. So it will be somewhere like this. From the base, keeping this as a turn, you will mark 135 degrees to the left, and this is how he will turn. Okay, and he'll go, let's say 10 more meters here. Right? Now from here, he takes another right at 45 degrees. Another right at 45 degrees and goes for 30 meters. So from here he is taking another right at 45 degrees. So again we will increase this as the baseline, and right means this side 45 degrees. So this much. So he will turn this much, 45 degrees, and he will move forward to reach 30 meters more, and he will end up at this point. This is point B. So this has been his journey. Okay, this has been his journey. So if you are just talking about left and right, that is pretty simple. You can post it, you can draw it without any problem. You can trace it without any issue. But the moment angular turns come into picture, angles of this sort, then for a lot of students it becomes difficult. So if you approach it in this way, you will be able to understand better what is my baseline and how do I have to turn. For a lot of people, 135 degree turn means this. So they say that this is 135 degree, but this is not 135 right. Your turn always has to be with this base. So this is just 45 degree turn. Okay, so you will end up marking it incorrectly if you don't know how to turn angularly. Right? So that's it. We'll stop here today. So as far as the theory is concerned, that's all for directions which I have to share with you. Tomorrow I'll be getting very good questions, a good mix of questions, some previous year, some normal practice questions. Some will be of good level, will be calculative, some will be very direct and easy. So you can approach it that way and we'll be able to terminate the concept tomorrow, right? Tomorrow, while we are solving the questions, I'll tell you some more things which you can, just make a note of. If you are comfortable, you can remember that also. Things like, if it is only asking you the direction, not the distance, direction of facing in the end. So they will tell you that a person is moving 100 meters north, then taking a right, going 20 meters right, then taking a left, going 30 meters, then taking another right, going 50 meters. Where is he facing now? So in these cases, you don't actually have to, so make the figure. You can do it while making the figure also, but you can actually just do it verbally. So each time you make a left plus right or right plus left movement, your movement gets cancelled. Because if you're facing a particular direction, you're taking a right and then a left, you'll still face the same direction. Or you're taking a left and a right, you're still facing the same direction. So this will help you only when you're looking at if the question is asking you in which direction is he finally facing. Then you can simply cancel out LR, LR, LR. Wherever left, right comes, cancel out. Wherever left and left or right and right comes, keep adding the movements. Okay, so you can immediately, just by reading the question, you can get your final direction. So I'll show that to you once or twice when we are doing the questions. That ways you can solve it, maybe you can save a second or two here or there. But again, that is your choice. I don't do that personally. Personally, I recommend to use figures only, because one method fits all is actually the best method. I don't want different methods for each type. That wastes time. Okay. So I'll end it here, and I'll see you guys tomorrow. Till then, you guys take care. Do subscribe to the channel and hit the like button if you like the content, if you've understood what I tried to share with you. And this was directions from ground up, from ground zero, right? Thank you so much for joining live, guys. Bye-bye. Namaskar. Jai Hind. See you guys tomorrow.